9. I know I got a bunch of you missing for this part 1 lesson, so I'm going to do the best that I can and give this to you through a video, and hopefully my computer doesn't lock up on me. But this chapter, for the first part of chapter 9, we are going to be graphing quadratic functions. If you remember back from the 8th grade curriculum, a quadratic function graphs as a curve, something like this. They started really basic last year in the 8th grade curriculum, and they're very simple. These are called parabolas. Right here it is, parabola, not parabola, parabola. And then we have a vertex. The vertex is this point, the very, very lowest point, or if it's going the other way, the very, very highest point of your curve is considered your vertex. Within that vertex, you will always have the axis of symmetry, because a parabola will always be symmetric, meaning if I drew a vertical line, I could fold it over and it will be symmetric. So whatever x coordinate of your vertex is, that is your axis of symmetry. So x equals whatever it might be. There is a formula to calculate that given any quadratic function. Remember, a quadratic function has the highest degree of a 2. So the coefficient in front of the x term is always referred to as x squared term is a, and then the one in front of the x squared is b, and then the constant is c. That's the number without the variable. Okay, so they say a cannot be 0, and a can't be 0 because in order to be a quadratic function, you have to have an x squared. So in order to, you can actually use this standard form with your a, b, and c numbers and calculate right here the axis of symmetry, or the x coordinate of your vertex. So down here, the other thing that we should talk about is that if this a is a positive number, that it opens upwards, so it looks like a happy face. And if it is less than 0 or a negative number, you know, it's a negative Nelly, so it's going to look like that and open downwards. And then your vertex will either be a minimum value or a maximum, as high as it goes, the highest point or the lowest point. So we are going to graph quadratic functions. That's where we're going to start off first. So we have to start with plugging numbers in. Now, I'm going to tell you, you should find that x, you remember it's symmetrical, so it's going to be the same on the right and the left. So if I can find my vertex, or at least my x value of the vertex, that's kind of where I want to start, and then I want to branch out either way. So here that is, x equals negative b over 2a. In this case, here's your a is 1, your b is 6, and your c is 8. So I'm going to plug that into that equation. A negative 6 over 2 times 1, and simplify. So negative 6 over 2, or negative 3. So I'm going to go ahead and plug that in my center, because that's my vertex. Everything that goes on either side of that. So I'm going to plug that in there. I'm going to go smaller, so negative 2, negative 1, 0, and I'm going to go ahead and do negative 4, negative 5, negative 6, and see if I can get them all on there. So now all I'm going to do is plug those values into this quadratic function to find the y-coordinate, starting with my vertex, because that's a good starting point. So 3 squared, negative 3 squared, and plus 6 times negative 3 plus 8. This is going to be 9 minus 18 plus 8. So that would give me a negative 1. So guess what? My vertex is at negative 3, negative 1. Negative 3, negative 1. There is my vertex. I know it's going to open upward because a is positive. All right, now let's put negative 2 in there. We'll square negative 2, I get 4. Negative 2 times 6, I get negative 12. And then plus 8, if I simplify that, I get 0. put negative 1 in there. Negative 1 squared is 1. Negative 1 times 6 is negative 6, and plus 8 gives me a positive 3. And then 0, that's easy. 0 minus 0 plus 8, I get 8. So I can plot those, I think. Can I? So let's see here. Negative 3, negative 1, good. Negative 2, 0. Negative 1, 3. And 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, let's go to the other side, a negative 4. Now, it's symmetric, so a negative 4 better come out as 0, but I'm going to double check. Negative 4 squared is 16. Negative 4 times 6 gives me negative 24 plus 8. And does that come out as a 0? Yes, it does. Negative 5 squared is 25. Negative 5 times 6 is negative 30 plus 8 gives me a positive 3. And you know what? Frankly, I can't even do negative 6 because negative 5 is as far as I can go. But I'll bet you can figure it out. It'd be 8. So I've got negative 4, 0, negative 5, 3. And now we're going to go ahead and connect our dots with a nice, smooth curve. So, domain, what are the possible values for x? It is always all real numbers. As long as they're real, I can move anywhere, left or right. But what values in my function is y ever going to be? Now, y is up and down. Notice, none of my function goes below my vertex. So y has to be greater than or equal to negative 1. It opens upward. My axis of my vertex is negative 3, negative 1. My axis of symmetry is x equals negative 3. There you have it. All right, so let's talk about all of those things I just referenced right here. If it opens upward, by the way, that means there's a minimum, because this is as low as we go. So, right here is my parabola. Here's another example. So since my vertex is negative 1, negative 6, axis of symmetry is x equals negative 1, whatever your vertex is. And then because it opens upward, I know there's a minimum value, and I know that my minimum value is negative 6. So then my range is going to be y has to be greater than or equal to negative 6. So it opens upward. There's a minimum value, an axis, all those things. So that's what we're going to be referencing. So let's turn our babe over. Take a look at this. The graph is already made for you. From that graph, you should be able to identify your vertex. It's right at the very top or right at the very bottom. So in this first one, what's our vertex? It's right there on the y-axis, so 0, 4. Our axis of symmetry is actually the x-axis, which would be x equals 0. And our y-intercept, remember our y-intercept is where it crosses the y-axis. So believe it or not, it's actually 4, because it's right on the origin. Okay, this next one's not quite as easy as that. Pretty close though. So what's the vertex? Right here, it is 2, 0. X is 2, y is 0. Our axis of symmetry is right here, which is x equals 2. Then our y-intercept, where does our graph cross the y-axis? It is right, kind of in between there. So it looks like 1, 2, 3, 4.5. So 0, 4.5, approximately. All right, so what if They don't give you the graph, they just give you the function. And I still want you to find those things. Well, remember, to find our axis of symmetry, it's x equals negative b over 2a. All right, so here we go. This is, now remember, and I guess I shouldn't have had to write that. It's right here. So if to find my axis of symmetry, remember, a is 1, b is negative 6, c is 3. So I've got a negative 6 over 2 times 1. If I have a negative, guess what? It makes it positive 3. So x equals 3 is my axis of symmetry. How do I find the vertex? Well, I already know the x-coordinate is 3. How am I going to find the y-coordinate? I'm going to substitute that 3 into this equation. So the y would equal 3 squared minus 6 times 3 plus 3. So 9 minus 18 plus 3, which would be a negative 6. So our vertex is 3, comma, negative 6. The x-coordinate we solved for and the y-coordinate we got by substituting it in. Then the y-intercept, meaning where will our graph cross the y-axis? Well, if it's a point on the y-axis, then x has to be 0. So take your equation and make all the x's 0. If you do that, you get 0 minus 0 plus 3, and our y-intercept is 3, or 0, comma, 3. Let's do that again, starting with axis of symmetry. Remember, that is x equals negative b, so 8 over 2a, and in this case, a is 2. So 2 times 2 is 4. 8 divided by 4 is 2, so a negative 2. So axis of symmetry, x equals negative 2. How am I going to find my vertex? I'm going to take my value of the x for my axis of symmetry, or my vertex. I'm going to plug it into my equation to find what the y value is. So y equals 2 times negative 2 squared plus 8 times negative 2 minus 1. Well, when I square that negative 2, remember that's a positive 4. 4 times 2 gives me 8. This gives me a negative 16, and this gives me a negative 1, which would be negative 9. So y equals negative 9. Our vertex now then is negative 2 for x and a negative 9 for y. Our y-intercept, meaning what is y when x equals 0? So y equals 2 times 0 squared plus 8 times 0 minus 1, or 0 plus 0 minus 1. What's our y-intercept? Negative 1, or 0, comma, negative 1. And those are our 3 things. Those are the main things we're going to talk about. I'm not sure in your lesson if I've talked about maximum or minimum, but remember, if it that's kind of talked about right here, and I will review this again on Monday, but remember, if it is positive and it goes upwards, this is as low as it goes. If it's a negative a and it goes down, then this is going to be as high as you get, or the maximum height. All right, remember, your domain is always going to be all real numbers. And your y, your range, is always going to be either less than or equal to y, or greater than or equal to your y of your vertex. Okay, so we're going to stop there for the lesson, and we will finish the rest of these notes on Monday, where we will also review again. But your assignment on your pink sheet is not this. It is actually going to be 28 through 42. So 28 through 42, all. So in those, you're talking about the vertex, the equation, the axis of symmetry, remember, which is x equals negative b over 2a. The y-intercept, which you plug in 0, make x equals 0 and solve for y. And finding the vertex, you use that and plug it in if you don't get the picture. All right, that is where we're going to start today. On Monday, we will talk about graphing these functions and talking more about the minimum and the maximum value and the range and the domain of a function. But for now, have a great weekend. Hopefully you get this done. Come see me if you have any questions. All right, thanks.